So let's talk a bit about concentration and amounts. So the concentration of a solution can be measured in terms, first of all, of mass. So a solution concentration can be measured in grams per decimeter cubed, and that's the same as the mass of the substance divided by the volume. So the mass in grams divided by the volume in decimeters cubed. You can also measure concentration in terms of solution concentration. So that's moles per dm cubed. And that's the amount of the substance, the number of moles, divided by the volume in decimeter cubed, dm cubed. So the amount of the substance in moles divided by the volume in decimeter cubed. So let's recap some of that. Those two units that we've got moles per dm cubed, and we've got grams per dm cubed. They're the two different measurements of concentration that we need to know. Now, if a solution contains 12 grams of a substance and has a volume of 60 dm cubed, what is the concentration of the solution? So remember the concentration, how to calculate the concentration. We're going to do it using the mass in this example because we're given the mass in the question. So the concentration of solution in grams per dm cubed will be the mass of the substance divided by the volume of the substance. And then substituting in those values, the mass was 12 grams and the volume was 60 decimeter cubed. So 12 grams divided by 60 decimeter cubed equals 0.2 grams per dm cubed. So we can use information about a solution to work out which chemicals were in there to start. So the concentration of a solution can be calculated if we know the volumes of the two solutions that react completely and the concentration of one of these solutions. And we can calculate the amount of solute, so that's the stuff that's dissolved in a substance, in a solution if we know either both the concentration of the solution and the volume of the solution. So to recap that, if we know the volume of two solutions that react completely and we know the concentration of one of them, then we can calculate the concentration of the other. The ratio of moles between substances X and Y is 3 to 2. If there are 9 moles of substance X, how many moles are there of substance Y? So you're going to need to get your maths hat on for this. If we've got a X to Y ratio of moles of 3 to 2, and there are 9 moles of X, then dividing 9 by 3 will give me 3. And multiplying it by 2 to find out how much Y there is will tell me that there's 6 moles of substance Y. And let's look at another example of how to calculate the concentration. So if I want to calculate the concentration of 6 grams of sodium chloride dissolved in 3 decimeters cubed of water, I first of all need to remember the equation. So concentration in grams per dm cubed is the mass in grams divided by the volume in decimeter cubed. And substituting in those values, well, we've got the mass of 6 grams and the volume of 3 decimeter cubed. So we do 6 grams divided by 3 decimeter cubed, which tells us the concentration is 2 grams per decimeter cubed. Now, at the same room temperature and pressure, equal amounts of gas, when they're measured in moles, will take up the same volume. Okay, so at room temperature, which is 20 degrees Celsius, and pressure, which is 1 atmosphere, 1 mole of any gas will occupy a fixed amount of volume, and that volume is 24 decimeter cubed. And when we're calculating volumes, where we can think of if we're given the volume of 1 gas involved in the reaction between gases, then a balanced equation for the reaction can be used to calculate the volume of the other component. So again, let's think of an example of this. So if the ratio of gas A moles to gas B moles is 5:2, then what is the ratio of gas A volume to gas B volume? So remember, 1 mole of any gas takes up the same space, so the ratio will be exactly the same. 5 moles of gas A will be the same as will have the same. So the moles of gas, sorry, the volume of gas A and gas B will be the same as the ratio of the number of moles. That's 5:2. So what are the values for room temperature and pressure? So remember, we've got 20 degrees Celsius and 1 atmosphere. That's room temperature and pressure. And to run through some definitions, the mixture formed when a solute has dissolved in a solvent is a solution. The liquid in which a solute dissolves is called a solvent. And the substance that dissolves in a liquid where to form a solution is called the solute. And just to remember again, see if you can remember this, room temperature and pressure. What is that? So it's 20 degrees Celsius and it's 1 atmosphere.